Hello everyone and welcome to SE312 Electronic Data Communications. I am Professor Prabodhu Pathirana and I am the Unit Chair for this course. I will be taking your seminars and your practical sessions during this trimester. Please refer to the timetables for the specific class seminar and laboratory times indicated there. Whenever there is a possibility of recording, we will make sure that all off-campus students have access to those recordings. In addition to that, we will be running off-campus online seminars and practical sessions to support everyone. By the end of this semester, you should reach several key learning milestones. You should understand the basic hardware and software components that are commonly found in a data communication system. You will also be able to explain the need for various protocols and describe current networking paradigms at a theoretical level. This includes being able to describe various types of computer networks and understanding advanced high-speed network technologies. Finally, you will become familiar with the TCP/IP protocol and its overall architecture. This unit has adapted to a blended delivery model, meaning lecture videos and notes will be available weekly. We expect you to follow these videos and go through the slides carefully. If you have any questions, I encourage you to raise them during the seminar times, which are traditionally our tutorials. The goal is to provide a solid grounding in the basic principles of data communications and networking. This field has evolved quite rapidly with the involvement of many corporate and academic sectors. While it often takes many years for a technical professional to gain a deep insight into these systems, this unit will provide the much needed theoretical foundation. For our prescribed text, we closely follow the book titled Data and Computer Communications, 10th edition by William Stallings. While there are several editions available, if you can find a textbook close to the 10th edition, it will be sufficient for this course. The fact that this book has reached 10 editions shows the rapid progression of technology in this space over a relatively small period of time. This is a widely used textbook across the world, and we aim to follow its structure and content quite closely. Next, let us discuss how you will be assessed in this unit. There are 4 main assessments. Assignment 1 and Assignment 2 are both quizzes worth 10% each. These are conducted through Cloud Deacon and have strict deadlines for completion. Assignment 3 is a laboratory report worth 30%. This is partially a practical report and partially an assignment, divided into Part A and Part B. Part B is predominantly based on the laboratory sessions we intend to run. The final assessment is the examination, which is worth 50%. This is a 2-hour online exam based on Cloud Deacon. For Assignment 3, 10% of the grade is based specifically on how well you present your report. We are trying to mimic a professional environment such as a research and development firm where your manager asks you for a report. While most questions have definitive answers, we prefer a typed report over a handwritten one, and we encourage the use of software tools to create professional figures. If any area is not clear, please email me to clarify or arrange a Zoom session. The responsibility is on you to clarify your understanding before the deadlines. Now we will begin the first lecture, which is based on Chapter 1 of the Stallings book. This chapter covers data communications, data networks, and the Internet. In this chapter, we are trying to give you an overall big picture idea of the subject. This big picture is very important because when we talk about separate areas in detail later, having this foundation prevents the subject from becoming confusing. We should never lose sight of how individual pieces fit into the larger picture as we progress through the broad area of networking. The Stallings book usually includes a significant quote at the start of each chapter. For this chapter, we look at a concept from Claude Shannon, who is considered the father of modern telecommunications. He stated that the fundamental problem of communication is that of reproducing a message at a different point than where it was created, either exactly or approximately. Effective and efficient data communication facilities are vital to any enterprise. In this section, we first look at the trends that increase the challenge for business managers in planning and managing these facilities, and then we look specifically at the requirement for ever greater transmission speeds and network capacity. Three different forces have consistently driven the architecture and evolution of data communications and networking facilities. These are traffic growth, the development of new services, and advances in technology. Regarding communication traffic, both local traffic within a building and long-distance traffic have been growing at a high and steady rate for decades. Network traffic is no longer limited to just voice and data, it increasingly includes images and video. There is an increasing business emphasis on web services, remote access, online transactions and social networking, which means this trend is likely to continue. Business managers are constantly pressured to increase communication capacity in cost-effective ways. New and demanding services require more bandwidth. As businesses rely more on information technology, the range of services users want to consume is expanding. For example, mobile broadband traffic is exploding because of the amount of data pushed through smartphones and tablets. Users are increasingly demanding high-quality services to support high-resolution camera phones, video streams and high-end audio. To keep up with this mushroom in traffic, service providers must invest in high-capacity networking. In turn, the growth in high-speed offerings encourages the expansion of even more mobile applications and services. Growth in services and traffic capacity go hand in hand. As an example, we can look at a chart showing the mix of traffic and the growth trend for cable internet subscribers between January 2010 and January 2011. Although this data is from a decade ago, it provides a clear insight into the generation of network traffic. You can see that the average data rate per subscriber for streaming media more than doubled in just 1 year. This was the most significant increase compared to other protocols such as web browsing or peer-to-peer communication. This illustrates the ever-increasing need for capacity and speed in modern networks. There are 4 notable technology trends that are particularly important. First is the trend toward faster and cheaper computing and communication. More powerful computers can support demanding multimedia applications, while optical fibre and high-speed wireless have brought prices down and increased capacity. Second, today's networks are more intelligent. They offer differing levels of quality of service, which include specifications for maximum delay and minimum throughput. They also provide customizable services for network management and security. Third, the internet, the web and associated applications have emerged as dominant features for both business and personal landscapes. The migration toward everything over IP continues, and enterprises use intranets and extranets to isolate proprietary information. Finally, mobility is the newest frontier. Devices like the iPhone and iPad have become drivers of network evolution. Enterprise applications that were once limited to desktop computers are now routinely delivered on mobile devices. Cloud computing is being embraced by major software vendors like SAP, Oracle and Microsoft, ensuring that mobility innovations will continue to grow. This chart indicates the demand trend for Ethernet data rates. Usage statistics indicate that Internet backbone data rate demand doubles approximately every 18 months. Meanwhile, demand in the enterprise, server and local area network space doubles approximately every 24 months. This shows that the requirements for data transmission over these years have had a greater effect on wide area networks than on local area networks, but both continue to rise significantly on this logarithmic scale. Momentous changes in the way organisations do business and process information have been driven by changes in networking technology. It is hard to separate what comes first, as it is a chicken and egg situation in this field. The use of the internet by both businesses and individuals reflects a cyclic dependency. The availability of new image-based services on the web results in an increase in users and traffic volume. This in turn results in a need to increase the speed and efficiency of the internet. Only such increased speed makes the use of web-based applications palatable to the end user. Regarding the emergence of high-speed local area networks, personal computers and workstations have become essential tools for office workers, almost reaching the status of a telephone. In the past, these networks provided basic connectivity to mainframes, but now they are essential computing platforms. There are several requirements that call for higher speed networks. One is centralised server farms, where users need to draw huge amounts of data from multiple servers. An example of this is a colour publishing operation, where servers contain tens of gigabytes of image data that must be downloaded to workstations. We also have power work groups such as a software development group or a computer-aided design company which share massive files and run simulations at high speeds. Finally, high-speed local backbones are necessary as processing demand grows and networks proliferate at a site. Corporate wide area networking needs have also changed. In the early 1990s, there was an emphasis on centralised data processing with mainframes. Today, employees are dispersed into smaller offices and there is a growing use of telecommuting. Applications have shifted toward client-server models and intranet computing. There is now much more reliance on personal computers and data-intensive applications. We used to follow a rule where 80% of traffic remains local and 20% traverses wide area links, but this no longer applies to most companies. A greater percentage of traffic is now going into the wide area environment, which puts a larger burden on network facilities. The rapid conversion of consumer electronics to digital technology is having a major impact on both the internet and corporate intranets. Image and video traffic is increasing dramatically. Two noteworthy examples of this trend are digital versatile discs, or DVDs, and digital still cameras. DVDs replaced analog VHS tapes and took video into the digital age, allowing vast volumes of data to be crammed onto a disc. Digital camcorders have also made it easier to create and share video files. These improvements in digital electronics have necessitated that networks support higher data rates. An example of this is how we used to install software like MATLAB using several CD-ROMs, but now it is delivered entirely through the network despite the program being much larger and more complex. This illustrates the dual relationship where technology makes networks more capable while also creating more data-heavy applications.